Okay, let's have a go at this question, which I think is page 24 for you. So we are looking at quite a horrendous question. You've been given far too little space at the bottom to do it here, so I'd be looking at some lined paper or something. It's about as hard as these questions become, but I want to convince you that it's not nearly as hard as it looks. So let's break it down. A white solid is a mixture of these things and an inert solid, so 3 things in my solid, and we've got a volumetric flask involved. So I find it useful to think about what's actually going on in these. Okay, so what I've got is some solid. Ooh, let's have that pen. Here's my solid, and it's got 3 components to it. 1, 2, 3, and we don't know how much of each one there is, but we do know what they are. We know that one of them is not going to react at all, and we've got 1.90. Actually, I'll tell you what. Here's a better way. The way of showing those will be for me to put a sticky note on it. 1.90 grams. Okay, and we're going to put it into a big, a bit of lag there, a big volumetric flask. There's the water line. And the big volumetric flask is going to be 250 centimeters cubed. So that's all going into there. And I'll shake it up and invert it. Right, this is where it starts to look complicated. 2 different titrations were carried out with it. Let's just look at both together for a moment. The first and the second, 25 centimeters cubed were added to that, 25 centimeters cubed were added to that. So the way we're going to think about the rest of this question, we're going to continue with this drawing thing, and we're going to go to that side, maybe a little further than that in a minute, and to that side. We're going to grab a pipette or something which is accurately made out of 25 centimeters cubed, and so we're going to have 25 centimeters cubed over there, and we're going to have 25 centimeters cubed over there, and that's going to help us out in a minute. So we need to look at them together now. So that's what's going on in there, and now we'll look at the first titration. So, oh, there's one more thing actually I forgot to say. This dihydrate bit here, we can actually just ignore. Okay, we don't need to worry about that, and that's partly because of what we do in the rest of the practical to get rid of it. We can just treat that as the ethane dioic acid. So, adding to the sulfuric acid, and that we can also basically ignore for the calculation. It looks like, you might feel like it's going to make a difference. It's not going to make a huge amount of difference to our calculation. The important thing is that this process, which is then going to lead to us being able to do this titration, is going to mean that all of the ethane dioic acid is going to be in this form, and all of the sodium ethane dioate, sorry, I showed you both there, didn't I? Both of these things are going to end up reacting like this in this titration. Okay, so that accounts for both. That's because we've heated it up with our acid. Where have my lines gone? Oh, well, you got the idea, didn't you? $25 over there, $25 over there. So that means we're going to have the acid. Hang on. So I haven't tried this before, that's why there's a few a few issues with it. That's going to be the acid and the diurate. This is going to be the acid only at that end. Oops. Okay. So that's the acid and the diurate. Down here in titration 2 is what I just said. That's only going to be coming from the acid. So that's an acid-based titration like you were, well, you actually did the GCSE a little bit of that. This one is the new type of titration that we've got in this booklet. This is one of the equations you could just learn, so you know when you're confronted with one of these questions, you've got this reaction, this equation here. So now that we've divided it into 2, we can quite easily start taking information out of it. And one recommendation, one exam tip of mine is always, if you're faced with a horrible question like this with loads of words, you're probably going to get some marks just for doing some concentration calculations. So there's going to be 1 mark available here for that value and doing a concentration, or using the concentration equation to work out how many moles there were. So that's what we're going to be doing. Let's look at that question, and I'm actually going to do this quite quickly for a number of reasons. But this is the reaction after we've heated it with the acid to make sure we've got the diurate and the ethane diuric acid behaving like this. We're going to write in the equation, which hopefully I can just copy and paste here. Well, we're going to write in the bit of the equation we're interested in, which is those two, as you're used to by now. We're interested in those 2 bits of the equation. And let's see what we know about. Well, the manganate, the potassium permanganate, that beautiful purple stuff. Do we know its concentration? Yes, we do. I'm not going to write them in. Do we know its volume? Yes, we do. Okay, work out its moles. Well, if we do concentration times volume, we end up with 5.3 times 10 to the minus 4. Now, next job, we actually want to know how many moles there are of this. So, the method I like to use, I'm going to draw a nice big arrow, going up to that. What's the relationship? Well, I've got 2 over there. Let's make that a bit bigger. 2 and 5. So, how do I go from the 2 to the 5? Well, I've got to times by 5 over 2. 5 over 2 gives me another number of moles. Gives me 1.32 times 10 to the minus 3. Okay, so that's nice. That's several marks for that bit. I'll put it there so we can see all of it. So now we know what's going on with that titration. Let's look at the other one. The other one's simpler, and it's just going to be the acid. So let's do exactly the same thing again. I don't know why I've got that left there. Copy all that there. There's my equation. Again, there's an easy mark available for looking at what we know, where we know some sodium hydroxide and we know how much was added in. So let's try and be consistent. Do I know the sodium hydroxide's concentration? Yes, I do. Do I know its volume? Yes. Can I work out how many moles were involved? Same as a moment ago, 1.045 times 10 to the minus 3. And that means same again, bit easier this time. Divide by 2 to get from the 2 to the 1. And that's, what does that come out as? I decided not to write it down, but I have got it written down. Oh, that won't be in the right place. We get an answer. Right, that will be, what is it in my head? It's about, what is it, 5 times 10 to the minus 4, approximately. So we've got 5 times 10 to the minus 4 is the number of moles of acid only. 1.32 times 10 to the minus 3 is the moles of acid and diowate together. Now the question is asking us, so I should probably have zoomed in on this earlier, is asking us about the sodium ethane diowate. So we want some number of moles of the ethane diowate. So we need to do acid plus diowate, take away acid. Easy. Let's make a nice big one. So I know this is a bit dodgy, this method of doing it. So moles of the Na2C2O4. Before we do that though, we want to account for our times 10. Let's do that now, before we start doing the rest of the calculation. So that's how many moles there are in this 25. That's why I wrote the 25s on. Okay, that's how many moles in 25s. So let's just put a times 10 over there. And we'll need a times 10 over there. And once we've done that, again, I'm not going to go through all these answers, partly in the interest of time. You can write that out yourselves. We're focusing on the method here. We're doing the left-hand side minus the right-hand side, as I've arranged it here. That, take away that. So we should be getting to 8.025 overall times 10 to the minus 4. I will need to just double check that. Is that before or after the minus 10s? Bear with me. 20. That has the minus 3 with those 10s accounted for. Okay. Then the rest should be self-explanatory, hopefully. We know how many moles of the sodium ethane diowate there are. And we want to have a look at what the mass is and therefore the percentage mass. So we could work out as MR turns out 134.0. So its mass, I'm going to zoom in a little bit on this actually, because I would appreciate you might want to see that. So its mass comes out as 1.075. Okay, once I've done moles, mass and MR, multiplied those two together. So its percentage mass equals that. I'm going to need some brackets here. All divided by what went in, which was 1.9 grams. All times by 100. And so my final answer, 56.6.